Okay, here we are doing section 6.2 now. Alright, so this one here we're going to start talking about quadrilaterals. We're going to focus mostly on parallelograms. This is going to kind of be where we begin, like parallelograms and their properties. Okay, so a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So if I draw it, it looks like this. Opposite sides. Opposite sides do not share a vertex. Opposite angles do not share a side. This is important to know. Here's a parallelogram because we're going to use these terms later on. So these side, those are opposite sides. This angle right here, opposite angles. Again, this angle over here. Ooh, I have lots of colors here, so hold on, people. Wait for it. Wait for it. Look at this light pink. Opposite, opposite. Those are opposite angles again. This one's like silver. Ooh, I haven't even used this one. Look, there's like a little thing on the top and tip of it. That was weird. Alright, again, opposite sides. Oh, that is cool. Alright, consecutive angles. I think my children were playing with my document camera. Opposite consecutive angles are angles of a polygon that share a side. Again, something important to know later on. So this angle and this angle would be considered consecutive. But this angle and this angle will be considered consecutive. And this angle and this angle will be considered consecutive. And this angle and this angle, because they share a side, okay? Alright, if a quadrilateral is a parallelogram, sometimes I'm just going to write parallelogram. So if it's a parallelogram, then its opposite sides are congruent. So what this is saying is this side is congruent to this side is congruent to this side. Ooh, fun time here for a proof. Alright, we got a picture over here. My given is AB is parallel to CD. BC is parallel to AD. And I want to prove that AB is congruent to CD and BC is congruent to AD. So I got my statements and I got my reasons. There's my given again. Okay. Alright. If I know that these are parallel, so I know that this side right here is parallel to this side. So if I think about this, and then I have this transversal right here. So that's going to tell me that this angle is congruent to this angle. And why is that? Because parallel lines mean that the alternate interior angles are congruent. But then remember too, we got this line being parallel to this line, and I still have that transversal, so now it makes these two angles. And again, it's the same reason there. Oh, now if you notice here, look, I got AC is congruent to AC. That's the reflexive property of congruence. And then, voila, I know that triangle ABC, this one right here, is congruent to triangle CDA because of what reason would it be? Well, you're right, because of angle side angle. And then, of course, if I have these two triangles congruent to each other, it's our favorite reason. I'll know that AB is congruent to CD. And BC is congruent to AD because of CPCTC. Yay. Alright, so what we got here then. Oops. Hold on, I lost what I was looking at here. Wrong class. Give me a second here. I just went to the wrong place. Alright, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. I should make sure I had the right theorem. If a quadrilateral is a parallelogram, then its opposite angles are congruent. We could, so if you think about it, so if you have a parallelogram, so this is parallel and this is parallel, right? And then these two sides are parallel to each other. So if I'm just looking at these lines right here, and there's a transversal, these two angles right here are going to be same side interior angles. So that's why they're going to be supplementary. Again, you could think about this line being parallel to this line, and that's the transversal. Then these two angles are same side interior angles, so hence the reason why they're supplementary. And then down here with your opposite angles, so the opposite angles being congruent. Actually, let me just go back up here. Up here we showed that those two triangles are congruent. Well, then you're going to know that this angle down here is congruent to this angle because of CPCTC. So we would also, so like the kind of the proof, you know, angle B is congruent to angle D because of CPCTC. And then we could draw another line this way and prove those triangles congruent and show that those two angles are congruent to each other either. Also, sorry. Okay, so now if I want to use this in a proof on here. So it says I'm given this, so then that means I have all the properties of a parallelogram. So all this stuff would be right here. It's my given. I'm being lazy. Okay, so I know that this is parallel to this, and 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 then I know that this whole side right here and this whole side right here are congruent. My goal is to show that this angle right here, BCD and CMD, are congruent. Okay, well, if I know that these two sides are congruent, then I know that those two base angles are congruent, right? So I know that angle BAD is congruent to angle CMD. So again, these two angles, oh, sorry, you can't see me. These two angles right there are congruent to each other because this is an isosceles triangle. So this, and this is the one, the regular isosceles triangle theorem. So when the sides are congruent, the opposite angles are congruent. 3 tells me, so then, okay, so now I have this congruent to this. But then I also know that those two are congruent because of what we just learned in the prior page. So then I can say angle BAD is congruent to angle BCD. So because if I have a parallelogram, opposite angles are congruent. So that was this last theorem, theorem 6.5. And then if I know that BAD is congruent to CMD, but BAD is also congruent to that, I can say this one is congruent to this one. And again, I can use the transitive property of congruence. Okay? All right. The next theorem says if a quadrilateral is a parallelogram, then its diagonals bisect each other. So what this is saying is that if I have a parallelogram, so here's one diagonal, here's another diagonal. That was a lousy diagonal. I still draw bad diagonals even if I'm at home. All right, so then these are congruent and these two are congruent to each other, okay? Oh, you love these problems here. Okay, so this is a parallelogram right here. Find x, PR, and SQ. Okay, so what this means here is this little piece right here is congruent to this little piece. So y is equal to x plus 1. And this little piece right here is congruent to this little piece. So 2x is equal to 3y minus 7. All right, what I'm going to do here, since this says y is equal to x plus 1, I'm just going to take this x plus 1 and substitute it in there for y. So then I have 2x is equal to 3x plus 1 minus 7. 2x is equal to 3x plus 3 minus 7. So then I get, let's see here. So I move that over there. I get negative x. 3 plus negative 3 minus 7 is negative 4. So then x is equal to 4. Then I just have to go back over here, plug it back in. X is equal to 5. Okay, so I got x. I got y. PR is equal to 3y minus 7 plus 2x. So it's equal to 3 times 5 minus 7 plus 2 times 4. So again, that's going to be 15 minus 7 plus another 8, so that's going to be 16. And then SQ, so x plus 1 plus y equals 4 plus 1 plus 5 equals 10. So I didn't, in a parallelogram, I didn't say that the diagonals are equal. I'm just saying that they bisect. So this one, this part right here is equal to this part, and this part right here is equal to this part. All right, this last one's doesn't have much to do with parallelogram, but it comes up in this chapter. So if 3 or more, sorry, I lost what I wanted to say again. 3 or more parallel lines cut off congruent segments on one transversal, then they cut up congruent segments on, I think it's all transversals, but hold on. Or every transversal. Okay. So what this is saying here, we've got, so these lines are supposed to be parallel. So if I have 3 or more parallel lines cutting off congruent segments, so if I know that these segments here are congruent to each other, then they cut off congruent segments on every transversal. So that means that these ones then are also congruent, okay? So in this example down here, again, you could try it and not, you know, just sit here and listen to me. You could challenge yourself right now. So we know that all those are equal to 6. We see that all these are parallel. I know that this whole thing is 15. So then what that means here is that if these are all equal to each other, then these little pieces all have to be equal to each other. If there's 3 of them and it's 15 there, then all I have to do is just do 15 divided by 3. I get 5, so CD is equal to 5. Okay? All right, let's look at a couple of these homework problems. You can see here that those proofs are underlined. I'm gonna look at these last ones real quick here. Okay, this one's really not too bad. This one we can do together. Again, these are all your proofs. let's see here. Let's look at 28 together and we'll look at this 41, okay? All right, so 28. 28 says, what are the values of x and y in the parallelogram? So there's a couple ways you could do this. I mean, you could say that these two angles are equal to each other, and then like 3y would be opposite with that one, but there's nothing there, so I can't really do that just yet. So I'm going to write that one down, but then I also know this right here, these two right here are consecutive angles. Remember, those lines right there are parallel, so then they're same side interior. So these two add up to 180. So then I have 4y is equal to 180. And then 180 divided by 4, I get 45. So y is 45. And then I can just easily, now that I have this equation over here, if this is 45, x is going to be 45 divided by 3. So then, I better check this, but I get 15. Yay. Okay, so that should have been pretty straightforward. And then I said we were going to do 41. Oops, I lost it. Okay, 41 says the perimeter of triangle ABCD, or sorry, not triangle, parallelogram. A, B, C, D. So you want to remember that all the letters just kind of go in order around the parallelogram. And it says the perimeter is 92. You also know that this side right here is the same as this side, and this side right here is the same as this side. So AB, so it says AD is 7 more than twice AB. So if I make AB X, I can make AD 7, so there's the 7, more, the plus, than twice AB. But again, that means this is the same because it's parallelogram, and it means this is the same because it's parallelogram. So then I just end up with x plus 2x plus 7 plus 2x plus 7 is supposed to be equal to 92. So when I, let's see, 6x plus 14 is equal to 92. Subtract the 14. 78. 6x is equal to 78. Divide by 6. X is equal to 13. So then it says me to find the lengths of all the 4 sides. So if x is equal to 13, AB is equal to CD, which is equal to 13. And then the other one, BC, is equal to AD, which is equal to 2 times 13 plus 7. So 2 times 13 plus 7, I get 33. So each of those are equal to 33. Okay. All right, that's it for lesson 6-2.